Welcome everybody. This is our weekly OPI lifecycle provisioning technical working group. As usual, the session is recorded and will be posted on YouTube channel afterwards. So I posted the agenda on the Slack channel. Let me reshare this once we have the recording going. So I wanted to chat today about three main items. First of all, want to just quickly go through the action items from last week and see if we have any still open gaps, so we can take a new action items for next week. From boot coordination perspective, what I think that I wrote here, and no, this is open forum, so feel free to comment as well. I think we have a very good three proposals currently on the page, and we should continue discussing that, that's for sure. But what I was thinking is maybe we can also try to tackle two new flows. One is what happens when host reboots, and one what happens when DPU reboots. And then see if the same three proposals kind of can help us achieving, or the three methods that described can help us achieving those kind of issues as well. Doesn't have to be, but I was thinking it's a good exercise to have at this point. Otherwise, we just a little bit too in the not getting enough perspective, I would say. So we'll open the floor for kind of this new discussion here. And the last piece, and maybe we can start with that. From the API work group, we received a request to standardize and help us resolve the problem, how we can uniquely identify VFs and PFs between what host sees and what DPU sees. Specifically, this came out from the Kubernetes deployment use case for the network offloading. Basically, the controller needs to create virtual and physical functions, and then on the DPU, we need to create network devices inside the DPUs, and we need to know how to correlate between the virtual physical functions on the host and the representations inside the DPU itself. If somebody already have an answer and it's kind of obvious and given how to do that, we're really open. Otherwise, we can just open the floor and talk about that. So any comments on the agenda before we deep dive? Any additions, rejections, suggestions? I'll give it a minute for people to gather their thoughts and get into the mood. Feel free to unmute yourselves and comment if you want.
So, Boris, I was looking at the coordination MD, and there was a number 4 on there that's not filled out, which is the BMC is on the DPU card use case.
Yeah.
So
Let me open that first.
Letting that one be for now.
Okay, so this is our coordination page, and what team is talking about. We have our first method, which is in-band PCIe. We have our second method proposed by Intel, the driver ready check, which is basically the option ROM. We have our third option, which is out-of-band platform management via BMC. And the fourth one, I'm not sure how it get here, but yeah, out-of-band using the DPU BMC. We didn't talk about this at all, team, so far. We can. I have no opinion to here or there, but thanks for noticing.
It's definitely a subset because not all DPUs have a BMC, but
yeah, when we discussed an option number 1, is we said the advantages, the pros of this option number 1 is it doesn't really require DPU BMC or even host BMC. This is, host to host, CPU to CPU kind of communication. It So that is the advantage of option number 2, having in-band. Same as the second option. This is kind of in-band. The third option is requiring the platform BMC to be there, but it doesn't require for DPU BMC to be there.
Although the XPU management role could be filled by
Be filled by the ARM cores, yes.
yeah.
This is why specifically we left it very obscure, vague, that this is management. Yep.
Yeah, I think that's maybe a pro of those two approaches. It allows you to have a middleman, meaning the DPU BMC that's coordinating the process and interacting with the platform BMC.
Any kind of entity on the DPU here, which is management, and we leave it to the DPU vendors to figure out whether they want this to be the discrete component like real BMC, or like with Intel, they have the IMC, which is integrated BMC, or like AMD Pensando, which running the management stack on the ARM cores. So I think we kind of combine, and this could be any of those solutions. We want to give flexibility to vendors to implement however they want. The key component here in this option number 3 is that server BMC is interacting with that entity over the well-defined protocols, and we don't really care who terminates on the DPU side, whether it's ARM cores, DPU, discrete component, or integrated controller. Make sense?
Yeah, makes sense.
Okay. Okay, any additions, changes, questions on the agenda? Cool. So I think we kind of discussed for several weeks already this topic of boot sequencing. And if you allow me, I want to spend kind of maybe 20 first minutes on the VFPF unique identification between the host and the DPU. If people already have, I see on the call a lot of people, so if people already figured out how to do this, just feel free to unmute yourself. Let's have an open discussion on this. So let me start with, until people getting comfortable to unmute themselves. So let me get started with, what is VFs and PFs definitions? What do we know about VFs and PFs, right? So we have basically usually the sequence number, right? From 1 to 256. We can tell DPU, for example, we want physical functions 2, 3, 4, and virtual functions related to that physical function. And people correct me if I'm wrong here. Once that physical or virtual functions getting hot plugged, the host itself is responsible for enumeration. So the host, the Linux, for example, as one use case, will enumerate and assign the BDF, bus device function address, to this virtual and physical function. So what we want to be able is to somehow uniquely identify that, either inside the same server or maybe even across the cluster in a kind of, if we have cluster environment like Kubernetes with different nodes. So one of the suggestions that came from the API group, if on that virtual physical function through some mechanism, and I'm thinking maybe, from the top of my head, VPD, we can present a serial number of the device plus some additional unique information, maybe UUID. But I'm really open to hear like what people did in their DPUs, IPUs, or what capabilities we have. I have quite a big representation here from DPU vendors and also from vendors. So feel free to.
So Boris, is the ask that every PF and VF presented to the host have a new mechanism that presents some sort of a unique tag for that function?
Yeah, the ask is basically how we can identify and match the virtual function presented to the host and the representation of it inside the DPU. We need that, for example, for IP assignment, right? If we want to be able to communicate between host operating system and DPU operating system, we would like to assign IP address to both sides in order for them to communicate over IP. And in order to do so, we need to know two ends of this function to uniquely identify, so we know how to assign IP addresses to them. Just one example.
So maybe just for my clarification, Boris, you are looking for like how can we map the virtual functions that exist or are provisioned on the DPU IPUs with what has been provisioned on the host and how they shall map with one another. Or in a nutshell, that's what you are after, or?
Yeah. Basically, every time we provision the virtual functions, and here DPU vendors, correct me if I'm wrong, right? We have here NVIDIA and Marvell and Intel. We have quite a big representation. So every time I provision a new virtual function, let's say, I can create it by giving physical functions ID. I say physical function 18, virtual function number 3.
So when you say provisions, the word, sorry to cut you.
Yeah.
Yeah, but on a DPU IPU level, the provisioning which you are mentioning, right?
Yeah. Somehow I send to DPU a command and say, hot plug me a new device. I know that for virtual function SRV, for example, the command comes from sysfs Linux on the host side. So that's also fine, right? You do echo sysfs into SRV. You say I want 3 virtual functions. I get in hot plug of 3 new physical PCI Express devices, each of them being enumerated by Linux and assigned BDF. Now on the host side, I see 3 devices with assigned BDF. And let's say it's network function, just for the sake of the argument. So far?
Yeah, okay.
Each of those functions have some kind of representations inside the DPU, right? For example,
for each VF on the host, there will be a corresponding VF on the DPU. So
thanks, yeah.
So okay.
Yeah, so for each VF on the host, we have a corresponding VF on the DPU, as Hasib saying, okay? And then we can, for example, if we use DPU with OVS technology, we can take that virtual functions inside the DPU, plug it into OVS switch, for example, and do whatever with it, right? Makes sense so far. Yeah.
So the ask is to be able to identify automatically which VF on the host corresponds to which VF on the DPU.
Yeah, if you have non-automatic way, let's discuss it as well, right? I'm just looking to how can we, let's say we want to establish a tunnel, like just run a simple application ping between DPU and the host over this physical function or virtual function. So we need to assign IP address to both ends, right? So I need somehow a method to identify which physical virtual functions on the DPU represented by the host and vice versa. Make sense? Hasib? Others?
Yes. I think there can be different methods to do it. But one way I think it is done is we have like a base PF, and all the VFs are incremented in number, like 1, 2, 3, 4, 5, like that,
Mhm,
for each subsequent VF
mhm.
on the. So so each
On
VF
which side you're saying? On the DPU
on
side or on
both
the host side?
sides. So the VF on VF1 on the host side will correspond to the next number on the DPU side. I mean, they will increment sequentially. That's one way to.
But on the host side, you have the BDF after PCI Express enumeration. There is no mapping today between BDF and virtual functions indexes, right? Or am I wrong?
Yeah, okay.
And if we, for example, re-enumerate for some reason or another device comes in, the enumeration, the BDF can change. It's all very dynamic.
I can comment about how NVIDIA does that in Bluefield.
Yeah, yeah,
Hey,
sure.
so we use, depending on the ownership mode, but let's say that such a behavior is required, like having some representation of every VF and PF on the host exposed on the DPU side. So we use something that's called representer port, NetDev representers. I come from the Silicon side of things, so I can't comment about it too much, but what I see from the documentation is that basically every instance on the host side is being expressed as a port instance. Let's assume, for example, that these are networking interfaces on the DPU side, and there is no replication of virtual functions and physical functions. One reason I could think about why we do that, that would be a huge waste. I mean, every physical or virtual function requires resources, and there is like a limitation on the total number of functions. So there is like a special type of physical function exposed to the DPU. In the documentation, we call it eCPF. And on top of that, all those representer ports are opened. There is a naming convention to these representer ports, so they could be easily mapped to the corresponding interface on the host side. And again, all what I see here is from public documentation, just a little bit of hands-on experience. If we want to dive into why we did that and how we did that deeper, we can do that. Maybe I can come better prepared on a future call.
Mm-hmm.
But if you look for like NVIDIA or DPU or Bluefield DPU representatives, you will see how it's done.
I think that will be helpful. And what you're saying on the high level, if I correct me if I misunderstood you, but you basically using the naming convention on the network interfaces themselves.
Yes. So I see, for example, that VF path representer, PF representer has PF in its name. For example, PF0 something something. If it's a virtual function representation, it will have both the corresponding PF and VF. For example, PF0, VF2. So that's yeah. So that's the naming convention. You're correct about BDF is dynamic. So I don't know if those names are changing dynamically based on how the BDF is assigned on the host. These are all things that are easy to check. But basically, I think the important takeaway is that there is no duplication of every VF and PF that are exposed to the host. I mean, that would be a way to do that, but that's very resource hungry, right? Because each one is has its own context, etc. Anyway, that's how I see we did that.
But that's why you're using scalable functions instead of fully virtual function, right?
Correct. Yes.
But the question is, the API group asked if we can also add somehow to query virtual physical functions in order to get some kind of ID, or not the index number, but maybe a serial number or UUID, maybe using, I don't know, VPD information or something like that, which is, I know, more static kind of thing. So maybe the naming convention is not, good enough or not unique enough.
I'm sure that there is uniqueness behind it. I wouldn't personally, I wouldn't use VPD data for anything. VPD is something that might be there, might not be there. Yeah, I saw plenty of cases where VPD just does not exist. I mean, not all system integrators put anything in there. I can check the uniqueness mechanism of representatives.
And when you say system integrators, you mean the board designers? Because basically this VPD that we're talking about is VPD of the GPU itself, right?
Yeah, but like, let's leave aside DPU. Let's imagine that a silicon provider just sells the chip to an integrator, and the integrator does not put VPD on there. I mean, for example, serial number. Serial number is a scheme that's determined by the provider, not of the silicon, but of the system. So most of them just put nothing there. I mean, NVIDIA, when we manufacture, we obviously put data on the VPD, but if we sell just the ASIC and not the system, then it's up to the integrator to put the VPD, and most of them just put nothing. So.
Okay. No, I just was confused about the system that you're talking about. You're talking about the
card,
the card itself. Yeah,
yes.
not the server, because we have here server representatives as well. So for them, system is the entire server.
Yeah, I just meant just the ASIC versus a whole card.
Yeah. Okay. Thanks. Haseeb, what you doing from Marvell side, or nothing, or you interested to listen to what NVIDIA does?
I will double check. I mean, I have not gone through that part yet, so I will double check how we do it, and then maybe I'll be much prepared next time.
Sure. Intel, somebody from
Yeah,
Intel?
same here, Boris. Actually, do you? I didn't dial into API call. Was it on a this week API call? I just want to get into exact requirements or questions they ask. So if it's already on YouTube, maybe then I can just go through it and see what's there. Because for me, it's still not clear what the problem is. Because yeah, we also, it sounds very similar to what was Eyal just explained. We also can have port representatives on host, but what is the problem? Is it problem because we can have control plane on our XPU cores and VFs or VSIs, whatever virtual ports there, and then we have these VFs on host. So
let
what is the root of this problem?
Let me try to explain.
Asking for.
Try to explain. I don't think that you will get much from the API call, because we briefly discussed it this week, a little bit last week, and a little bit the week before. So let me just summarize, try to explain it. And again, this is open for the group. If we don't think there is a value in this, be honest and open. What we think from the API group, the need is, let's say you send at once a command to create 10 virtual functions at once, okay? So you created 10 virtual functions. 10 virtual functions immediately hot plugged into your host and went through the dynamic enumeration and was assigned VDF on each and every one. So far, Andrei?
Yep.
Somehow, by magic, there is kind of representative of each of those 10 virtual functions on the DPU side. That's also correct.
Yes, because yeah, we need to know that we have now this extra 10 VFs exposed to host.
Exactly. So now let's say we want to create a ping between host and DPU over specific virtual functions. In order to do the ping, we need to create the network device inside the DPU, the network device obviously on the host. That is done by the drivers, right? And once network device is up, we need to assign IP addresses on the virtual function network device on the host, on the representative network device inside the DPU, right? In order to do that, we need to know how these BDF virtual functions on the host, what is the port representative or scalable functions in NVIDIA, like which one from all those functions is match, right? Who is who? Create a mapping table. Make sense?
Mm-hmm.
Maybe I'm not explaining this, but feel free to ask.
I don't know if it helps, but maybe something a little less abstract. You know, one of the main things that we're working on right now is figuring out how to, you know, enable Kubernetes support, right? And so imagine you've got the control plane running down on the DPU, and it is trying to assign, you know, a virtual function up to a pod that's going to run on a host, right? And so there might be, you know, 20 virtual functions on this host, and Kubernetes on the control plane on the DPU needs to assign one of those for a pod that's going to run on the host. So it's going to assign a virtual function as viewed from the DPU. And then somehow something up on the host has to get information about, this is the VF that I want. Now look at all of the VFs that it sees on the host and pick the right one and assign that to the pod.
Yeah, that's a use case that was presented in the API group. Steven is absolutely correct. I thought to a little bit simplify it and just, you know, do the ping application between the host and the DPU just to have a little bit more simplistic approach. And for that, we need to assign IP address. So we need to figure out which virtual functions is represented by which interface on the DPU itself. But yeah, thanks for the context. Okay, so I think we can pause here on this topic. I'll put an action item, Eyal, for you to bring a little bit more information next week for the group.
Yeah, so specifically next week, I will be out. It's a holiday, but I will be happy to bring more information the week afterwards.
Okay, cool.
Okay.
And if you want to start offline, that's also fine. And then we can discuss the offline proposal after, you know, we review it online as well.
Okay, I'm new to this operation. How do we communicate offline? Is there like a Slack channel?
You have a Slack channel and you have the email list. So you can choose either of those.
Okay.
And if you're not on the Slack channel, I can add you. Just
please do.
Send me your email and I'll do it.
Okay.
Okay, so let's switch gears and continue working on the boot sequencing. Okay, let me share. So far, we've been talking about the boot coordination process. The boot coordination, as I want to remind you, this is part of this high-level page. The high-level page of entire boot sequencing, we identify several use cases. The first use case is initial boot up. So initial boot up is what we discussed so far. Basically, what happens when the server and DPU powered on at the same time, and then they need to synchronize the initial boot up. But I want to remind the group that we also have the DPU and the host reboot conversation. So I wanted to a little bit deep dive on this call on this use case, and then try to see if what we propose in the coordination, if we can reuse one of the three approaches that we have to also solve this problem. First of all, a question. Do you like how we organize the pages? The boot sequencing is a main page. I put the TLDR here in the beginning. So this is a high-level overview of all assumption, use cases, considerations. And for example, the first initial boot up part is detailed into coordination. And then in coordination, we only focus on the initial boot sequencing. So if we're going to talk about server rebooting and DPU rebooting, we can create a new page with the same hierarchy. That works for people? Too complex, too simplistic? Don't care, that's also fine.
I think it looks good, Boris. It's just nice to have it explained how you've organized it.
Yeah, okay, good. Okay. So if we okay with that approach, and we've been deep diving on the initial boot up coordination, so I want us to talk a little bit about the reboot. So let's talk a little bit about assumption and see how we kind of handle with that. So when we experience DPU reboot can be experienced, for example, as part of the firmware update of the DPU itself, right? During the lifecycle management, DPU can reboot itself. It can be either managed reboot or maybe unexpected reboot. But in any case, what we see that in most of the scenarios, we are going to expect the surprise removal of the DPU card from the host, and this will cause the host to crash. Okay. So we do recognize there are several domains inside the DPU. It's not a monolithic thing. So if you update just a high-level application on the DPU, that's probably not going to crash a host if you restart the application. If you kind of maybe update the operating system, maybe again, we can hold all the PCI Express behind the non-transparent bridge, and maybe in most of the cases, you will not experience the surprise removal or anything like that. But if you actually touch and upgrade the piece of PCI Express implementation itself, whether it's firmware or a software implementation, because we see both of those implementations in our DPU vendors, both the completely software-based PCI Express implementation and firmware-based and hardware-based. So in that case, you will experience a host crash. Why that happens? Even if you have down port containment, and we discussed it with Steven also, if you remember, Steven. So if you have a down port containment DPC, then the default behavior for Linux kernel is to try kind of gracefully reboot itself. Okay. The only, and I want to start the discussion, is how can we coordinate this reboot? If it's a managed reboot and we know that DPU is going to go down, for example, we initiated the firmware upgrade, we know that DPU is going to be down. How can we help coordinate that reboot of the DPU with the reboot of the host? We don't want the host to crash, Do we initiate the reboot or can we keep the host alive? This is a discussion that we want to have probably. And again, this is the first time probably that we're discussing this topic. So feel free to ask questions or raise concerns or saying that all of I'm talking about is completely irrelevant. That's also fine.
As far as the managed firmware upgrade or
Mhm.
whatever is concerned, I think that is a quite managed process and it should be handled by the software, right?
Mhm.
Because the software can tear down all the I/O first and then make sure that there is nothing going on that PCI card, and then when the firmware does upgrade and then send the command to upgrade the firmware, at that time there will be a hot swap. I mean, it will be a surprise removal of the card, but there will be nothing going on the I/O, so there should be no crash. And if the Linux supports hot plugging, then it should be handled, I think. But that's only in case of the managed one. But what happens if the DPU crashes? That's unmanaged one.
So a couple of comments. First of all, the Linux today, not talking about Windows and VMware, but Linux specifically today does not know how to handle the surprise removal of NICs. So today, the default behavior of Linux is to invoke the downport containment and then reboot itself. So if we want to change the behavior, we need to discuss that. If we don't want to change the behavior, we need to discuss how can we maybe, I don't know, turn off the PCI Express port or, I don't know, some kind of other weird behavior. That's number one. And the second comment is which software. If DPU is controlled by external software, do we need, and this is one of the questions I posted here, do we need DPU to somehow notify the host, I'm going to reboot myself now? And if that happens, the host can take action that, okay, DPU is going to reboot itself. I need to prepare myself for that. DPU, and this is very much resonates with me with our initial coordination. Initial coordination of initial boot up is host powers on DPU. DPU says, okay, I'm ready, completely powered on. You can continue enumeration and you continue the boot process from the CPU perspective of the host. I think this is very similar approach. Is one option is DPU somehow notifies the host that I'm going to reboot by request of application or by request of external management system, or maybe it's unexpected crash somehow, but DPU maybe in most of the cases can notify the host I'm going to reboot myself. Host can take some specific action. DPU can either wait or not wait for host to acknowledge, okay, you can reboot, I'm okay, or if host is untrusted, DPU can just, go ahead and reboot itself, or anyways reboot itself after some kind of timeout. This is kind of a realm of thinking that I'm having. What happens if DPU is rebooting itself and notification to the host?
I think in a perfect world, you would want some mechanism to guard and inform the host that the card is about to reboot and lose connectivity. Whether that's actually practical to implement in short order, that's a whole other question. But I think the random active administrators sending commands to devices to tell them to reboot will occur no matter what. And it's an overall posture question. Do you guard against it, or do you just have to deal with the after effect of someone crashed their workload because they rebooted their card?
So let's say that's a good comment. So let's say somebody wrote an application that can manage the host to keep it up by doing magic on the PCI Express bus or whatever, right? how this application, how this piece of software can get notified that DPU is going to reboot. So for the question that you asked regarding the mechanism, so this again relies back to our initial boot coordination approaches. So if we take in, for example, approach number 3, the out-of-band management via platform BMC, so potentially the DPU management component can notify, because there is a communication established between them for initial boot, right? So the server BMC communicates with DPU management, right? So and get the boot status. So if we already have these messages of get boot status and it can reply, okay, DPU is ready. So we can use the same communication channel to notify server BMC, for example, notify by DPU. DPU can notify that
The
I'm going to.
the challenge might be reliance upon direct BMC communication, because if we have anything that expects the BMC access, it's not uncommon for, at least in large bare metal infrastructures, for people to want to disable BMC to host communication, because it becomes a security vector for attack.
True, but if we're considering that option number 3, which is using the platform BMC, the initial boot coordination, that the same reasoning should apply to the use case of rebooting. If we can jump into solution number 1 and 2 without BMC involvement, and we can solve it over there, I'm all for that. Yeah.
Agreed completely.
Another point that I have is if say we do get this notification from the DPU to the host that okay, I'm going down.
Mhm.
So how complex will it be for all the workloads that are running on that DPU to be terminated, and how that is going to be managed? Because this is where we are basically performing this operation on a running system. So there will be a lot of workloads at that time, which will be running on that DPU. So if the DPU out of the blue sends a notification that, okay, I'm going to reset or I'm going to reboot or whatever, so all that workloads that are running on top of it have to be properly shut down or diverted to some other NIC.
Absolutely, and I think this is exactly one of the reasons to have this notification. If we can notify the host, then the application that is responsible for all of those workloads can take action and terminate gracefully all the workloads and maybe fail over to a different DPU or to a completely different server. Make sense, Hasib?
Yeah. Yeah, what I was thinking was, do we have to define that that process as well, like how it will fail over, or how will that traffic be terminated?
I don't think so. I think if we can just standardize how the notification process goes, then each application can, do whatever they feel it needs to be done.
Okay.
Boris, but is it just a simple notification we're talking about? Like GPU will say, I'm rebooting in 5, 4, 3, 2, 1, done. Or we're saying, I'm going to reboot, tell me when I can do it.
Excellent question.
And if you don't tell me in 10 seconds, I will reboot.
Yep. I think that's an excellent question. And I think I hinted about the answer, about my thinking about this problem before. I think that maybe it's, and this is again, open forum, we're just starting this discussion. So I'm thinking that, yeah, maybe DPU can notify host, I'm going to reboot. If host is completely untrusted, you cannot rely on his answer. But if host is trusted or, deployed in some safe environment, then maybe DPU can wait for timeout, let's say 10 seconds. If server says, okay, now you can reboot, then DPU reboots. If answer doesn't come in that period of time, DPU reboots anyways. Same with boot coordination. In boot coordination, you can see here that we have a timeout. If a GPU is not responding that I'm ready for a specific time period, host will boot anyways, regardless of what GPU does. Make sense, Andrei?
Yeah, so it means that again, in case of trusted host,
Uh-huh.
we can rely on some feedback from host,
Mhm.
and it says, yeah, you can reboot now. I done all my cleaning up. Everything is ready for you to go down. Or in case of untrusted, we can just notify and say, okay, I'm rebooting. I'm telling you that I'm going to reboot, and then it will not accept any
Messages
requests
back,
to postpone. Okay, like give me extra 10 seconds or whatever
Yep.
before I finish. Okay.
Something in that lines, yeah.
Mhm.
Hey, Boris, if you're interested, I'll throw out another option, and I know that this won't work for all the scenarios, but it will work for the Kubernetes scenario,
Mhm. Go ahead.
and that is do nothing.
Mhm.
So there's already going to have to be for Kubernetes some sort of magic for figuring out a correlation between a DPU and a host. But if you know that you're going to reboot a node for any reason, standard operating procedure for Kubernetes is you tell Kubernetes to, basically, shut down that node. So drain it, stop accepting new work, get all the existing work off of it. It's say, hey, I'm going to do maintenance on this node.
Mhm.
And then you do whatever you need to. If it reboots, if it crashes, whatever, don't care. All the
Mhm.
workloads have been moved off of it.
I like that. One of the additional use cases that I want to propose to that to the same workflow is what happens if GPU wants to reboot itself because it crashed and currently in the process of core dumping. If you will not notify the host potentially can shut down the server because it doesn't expect anything or yank power of the DPU, so you will lose that crash dump.
Also back to Stephen's comment, I mean, I would like to understand it better. I mean, are we saying that even in case of Kubernetes, because this is like two different separate security domains, the DPU and the host OS, and assuming they will be two different Kubernetes systems for the simplicity reasons, there should be some sort of a coordination needed, even in case of the Kubernetes, because Kubernetes as an orchestration engine will try to resolve
Did we lose Alok or did we lose me?
I'm still here. I think we lost a lot.
Okay. So maybe what Alok is asking about, still you need coordination, and maybe what Stephen you're saying is coordination is done by the Kubernetes components instead of us reinventing the messaging system.
Well, generally, maintenance in a Kubernetes cluster, I think, is done by the admin. So coordination is done by the admin.
Mhm.
Right? They say, this node, I need to do maintenance on it. So I'm going to cordon it off. I'm going to drain it. I wait for those operations to complete. Once it's drained, it means all the workloads have migrated off onto other nodes, right?
Yeah.
We need, as part of this, we need to figure out some way to correlate, the DPU node in Kubernetes and the host node in Kubernetes, so that we know to do these operations on both of them.
Mhm.
And but again, that's more of an admin action today for Kubernetes.
So before we run out of time, do this group feels that we need to create a new page with a new kind of diagrams? And then we can, have a little bit more visual in front of us, even if we eventually decide, like Steven's suggestion, do nothing, or we still see value for some use cases and we do some coordination. Is it something that is going to be helpful for the group for next week?
So going back to Steven's proposal about do nothing, I think it works fine in case if we have trusted host and we have a central control plane which controls both host applications running on host and applications like Kubernetes, whatever control plane running inside XPU. And in this case, yes, we can be easily, like control plane will easily create it in steps. Okay, first migrate all Kubernetes nodes from whatever VFs I'm going to shut down, and then we shut down IPU or reboot it, whatever. But I think there is a still use case when there is no central control plane or control plane does not have access to host. It knows only how to deal with XPU. And in this case, we need this mechanism just to prevent from system to reboot. I think it's what we started our call today, how we can prevent all this VFs disappearing. But in this case, what we will do, what we notify host, and then host will, again, if there is some mechanism of cleaning up, it can do it, or I don't know, maybe at least it will remove driver and bind driver from these devices, so host will not reboot something like this. I think we need to look at these two use cases. One, what?
Yeah, bind on my drivers or even disable the PCI Express port, and then you
So
will
it
not
will-
experience surprise removal from them.
Exactly. So it will not reboot your host system.
The question is which software on the host is going to do it? Are we patching Linux kernel for that, or it's going to be an application running? And then if so, how we get the notification to that application? Because I easily can see us, for example, in this option number 3, creating a messaging tunnel or reusing the same messaging tunnel between the DPU and the server BMC. But now from the server BMC, we need to get the notification to the host OS somehow.
Yeah, exactly. Now server BMC knows that IPU going to reboot, but then where this notification will be delivered at a higher level.
At least
first level.
server BMC knows about DPU is going to reboot, so server will not do anything disruptive for the DPU, like removing power, disabling the PCI, or switching off the power supplies.
Sorry, I lost the connection last time, so didn't follow the current discussion, but I'm not sure where exactly I dropped, but
Yeah, what Steven is saying that in Kubernetes case, usually the admin that will manage your nodes will drain the workload. So all the workload will migrate to other nodes, and then you can safely do whatever you want maintenance to your both host and DPU. So we don't need to worry about coordination or messaging between them. And Andre was saying that it only works in the trusted environment when host is trusted.
Yeah. Plus, I mean, my argument is like, I think for the simplicity, there will be 2 different Kubernetes clusters. And are we saying like So when the DPU has to reboot, it can drain the particular nodes for its own cluster and
So if you have two clusters, probably the infrastructure cluster is in charge, right? So infrastructure cluster will know there is something happening with DPU, DPU wants to reboot, or infrastructure cluster decides to reboot DPU. So it will control the tenant cluster in a way so the workloads are not disruptive, like removing all the workloads and draining the nodes and stuff like that.
yeah, but it still requires some actions from the infrastructure or management cluster to the tenant cluster, right? It does
Yeah.
not automatically detects because they are two separate domains or clusters, right?
Two separate
They-
domains, but the infrastructure is talking and monitoring and controlling the tenant cluster. This is
Yeah.
at least my understanding from the API work group that we discussed in the Kubernetes two cluster environment.
Yes, and that brings my point that okay, Kubernetes within its own ecosystem can manage the workloads and the nodes belonging to that cluster, but infrastructure cluster in this case has to at least send the notification or the action to perform certain action.
Mhm.
So
Okay, we're out of time today. I think it was kind of good discussion. I will try to create a new page. If there are any volunteers or driving this, I'm really glad if somebody can volunteer, because at some point I cannot really drive all discussions and all workloads. But I'll try to create a new page for this and put maybe initial diagram and maybe this subsection, and then we can have something concrete to actually discuss next week. But I do encourage this group of people to start working more offline. We have a lot of Slack communications, we have these pages, we're creating issues and pull requests. So please try to be more proactive and not wait for between the meetings, weekly meetings. All right, thank you and see you next week.
Thank you. Bye.